Welcome to This Explainer. Today, we're jumping straight into a massive biological mystery. We're going to unravel the incredibly complex, multidimensional link between diabetes and cancer. And look, this isn't just about blood sugar. It's a fascinating story of wild cellular signaling, surprising drug side effects, and how your metabolic health fundamentally alters your internal environment.
To really wrap our heads around the scale of this issue, just consider this number: 37 million. That is how many Americans are living with diabetes right now. It's basically the defining metabolic condition of our time, and its ripple effects go way, way beyond what we typically imagine.
But here's the truly wild part. 1 in 5 of those people, so a full 20%, have absolutely no idea they even have it. They are walking around every single day with elevated blood sugar, completely oblivious to the invisible changes happening right down at the cellular level.
And that silent metabolic shift? It's exactly why we're here today. The American Diabetes Association and the American Cancer Society put out a consensus report noting this heavy statistical overlap. Basically, they realized these two diseases tag team far too often for it to just be a coincidence. And that realization, it kicked off this intense, ongoing cellular detective story.
So here's our roadmap for This Explainer. First, the diabetes connection. Second, insulin, inflammation, and growth. Third, the prostate cancer paradox. Fourth, unexpected heroes, diabetes drugs. And finally, the new 2026 screening guidelines.
Okay, part 1, the diabetes-cancer connection, focusing on the statistical overlap.
Let's look at how type 2 diabetes actually elevates the risk for some highly specific cancers. We're talking liver, pancreas, endometrium, colon, rectum, breast, and bladder. But get this, for prostate cancer, the risk actually goes down. And for a bunch of other sites, there's no association whatsoever. So it's not just a blanket increase across the board, right? It's highly, highly specific. Which brings us to part 2, insulin, inflammation, and growth. These are our biological suspects.
So, meet suspect number 1, the insulin/IGF-1 axis. You know that in type 2 diabetes, the body gets resistant to insulin, so the pancreas just pumps out more and more of it to compensate. Well, this network of receptors, when it gets flooded and overactivated by all that extra insulin, it acts like a hyperactive switch for uncontrolled cellular growth.
Basically, chronic hyperinsulinemia, meaning those constantly high insulin levels, and chronic inflammation literally hijack your cellular machinery. It drives rapid cell division, it actually stops apoptosis, the body's natural cleanup system for damaged cells. On top of that, it suppresses a protein called SHBG, which spikes your free estrogen and testosterone. And those hormones? They can directly feed breast and endometrial cancers. Plus, you've got meta-inflammation, this constant state of oxidative stress just bathing your cells in inflammatory cytokines. It's the perfect storm for rogue cells to multiply. And this all ties right into the Warburg effect, where these mutating cells hijack their metabolism to gorge on massive amounts of glucose, literally using that excess blood sugar from the diabetes as direct fuel for cancer.
If you want a super simple way to visualize all this complex biology, think of that excess circulating insulin as fertilizer. Just like fertilizer makes weeds absolutely explode in a garden, hyperinsulinemia is silently acting as fertilizer for tumor development.
All right, moving to part 3, the prostate cancer paradox. Time for a biological plot twist. Okay, so if insulin is cellular fertilizer and diabetes means high insulin, why on earth does diabetes actually lower the risk of prostate cancer? It totally defies the logic we just laid out, right?
It's a huge paradox. Type 2 diabetes is strongly associated with a reduced risk of prostate cancer, and researchers are still actively trying to untangle exactly why this negative connection exists. Some theories suggest that over a long period, chronic diabetes might actually lower testosterone levels, essentially starving the prostate tumors of their primary fuel. Whatever the real mechanism is, it adds this crazy layer of complexity to the whole mystery.
Which leads us to part 4, unexpected heroes. Let's talk about diabetes drugs shifting cancer biology.
This might just be the most fascinating part of the whole story. Everyday diabetes meds are turning out to be double agents. They don't just lower blood sugar, they're actively altering cancer biology. Look at this. You've got metformin activating the AMPK pathway. You've got SGLT2 inhibitors like empagliflozin promoting cell death and dropping inflammation. And then there are GLP-1 receptor agonists like semaglutide, which are showing incredible potential to actually slow down tumor spread.
Let's zoom in on metformin for a second, probably the most famous of these double agents. It essentially shifts the cell's energy balance. It turns on AMPK, which is like the cell's conserve energy switch. And by doing that, it violently hits the brakes on mTOR. Now, mTOR is a key pathway cancer uses to synthesize proteins and grow. So metformin is basically cutting off the tumor's supply lines while simultaneously boosting your body's immune defenses right there in the tumor microenvironment. It's literally a metabolic roadblock for cancer.
And we definitely can't ignore the newer players. The emerging data on GLP-1 receptor agonists is mind-blowing. By helping drop weight and drastically reducing systemic inflammatory markers, these drugs are bridging the gap between metabolic health and oncology. They're actually showing they might lower the metastatic progression in obesity-related cancers, like colon and liver cancer. It's a total paradigm shift in how we think about treating disease.
All right, Part 5, the new 2026 screening guidelines. This is your action plan.
Because look, knowledge without action is just trivia, right? So let's look at the updated 2026 guidelines. Dr. Tronick and the medical community just laid out these clear age-based milestones. Universal screening for all adults now kicks in at age 35, period, regardless of weight. But look at how it shifts down. If you're 25, have a BMI over 25, and multiple risk factors, you need screening. And honestly, this is the tragic part. We're now having to screen overweight youth with risk factors starting at just 10 years old.
So what actually flags you for that early screening? If you hit that overweight BMI mark and have any of these, a first-degree relative with diabetes, you're in a high-risk ethnic group, a history of heart disease, PCOS, prior gestational diabetes, or even just high blood pressure and triglycerides, you really cannot afford to wait until you're 35. You've got to know your metabolic status now.
The good news? The screening is super straightforward. Step 1. Get a simple blood test, like an A1C, which just checks your average blood sugar over the last couple of months. Step 2. If you're in the normal range, awesome. Just repeat it every 3 years. Step 3. If you land in the pre-diabetic range, that's when you immediately start structured lifestyle interventions and keep an eye on it every year.
And listen, catching prediabetes early, it gives you a massive, massive window of opportunity. With structured diet and exercise interventions, you can actually reduce your risk of developing full-blown diabetes by an astounding 58%. Think about that. You literally have the power to just rewrite your health trajectory.
And if the screening does catch diabetes, jumping on treatment immediately cuts your risk of a heart attack or stroke by up to 50%. So early treatment isn't just about micromanaging some number on a glucose monitor, it's about protecting your heart, saving your kidneys, preserving your eyesight, and, as we've explored today, shutting off that cellular fertilizer that feeds cancer.
As we wrap up this explainer, I want to leave you with something to really think about. We've seen just how wildly intertwined our bodily systems are. Your metabolic health isn't some isolated thing. It's the literal environment every single cell in your body lives in. So I have to ask, if your metabolic health is the soil, what are you letting grow? Take control, follow the guidelines, and empower yourself. Thanks for joining me on this deep dive.